Welcome back to the channel, where we dive into the deep science that makes our universe tick. If you ask most people to picture our solar system, they imagine the plastic models from grade school science class, a neat, predictable clockwork of rocks and gas, spinning perfectly in their designated lanes. But modern space probes have proven that picture wrong. Our cosmic backyard is a violently dynamic, rule-breaking frontier, where nothing is exactly as it seems. Today, we're going on a myth-busting tour of the solar system's biggest plot twists. We're going to see how these chaotic events shape our existence, and why, if we trace the timeline back far enough, you might actually be a Martian. Let's start with Mercury. Orbiting roughly 3 times closer to the Sun than Earth, it's constantly bombarded by lethal radiation. A scorched rock at this distance should be bone dry. Yet Mercury harbors a massive secret. It holds vast amounts of frozen water ice. While Earth's axis tilts about 23 degrees, Mercury stands almost perfectly straight up and down. Sunlight never reaches the bottoms of the deep craters at its poles, creating permanent deep freezes. Planetary scientists estimate there are 1 trillion tons of ice preserved in these dark craters, enough to encase the entire city of Washington, D.C. in a frozen block 2 meters thick. Mercury hides another strange anomaly. Its iron core is huge compared to the size of the planet. The math suggests Mercury started out much larger, until an object the size of our moon slammed into it in a glancing hit-and-run collision. The impact stripped away the outer rocky mantle, and some researchers suspect that stolen material eventually became part of the Earth beneath your feet. Earth's relationship with its neighbors gets even stranger when we look at Mars. Today, it's a barren, waterless desert bombarded by radiation. But 4.5 billion years ago, infant Mars held deep liquid oceans, right up until a Pluto-sized asteroid slammed into the surface and boiled the water away. If early Martian life had formed in those oceans, that massive impact would have blasted microscopic bacterial spores out into the vacuum of space. This leads to the panspermia hypothesis, the idea that Martian microbes hitched a ride on ejected rocks and eventually crash-landed on Earth. Far from being isolated, dead rocks floating in the dark, the inner planets are active participants in Earth's deep history. If microscopic life really did jump from Mars to Earth, every living thing we see today evolved from those cosmic hitchhikers. Moving outward, we find Earth's twin, Venus. Early in their histories, Earth and Venus were nearly identical in size, mass, and composition. You'd expect Venus to be a hospitable tropical paradise. Instead, tens of thousands of early volcanoes dumped massive amounts of carbon dioxide into the air, triggering a runaway greenhouse effect. Today, 155 miles of toxic gas presses down on the surface, with 1,300 pounds per square inch of force. Venus gets its oppressive heat from the sun, trapping radiation in its atmosphere. Logically, the gas giants furthest from our star should be frozen solid and quiet. Jupiter shreds that assumption. Its great red spot is a monster cyclone larger than Earth, spinning at 250 miles per hour for over 3 centuries.
This storm isn't powered by the sun. Jupiter is actually shrinking, and the resulting gravitational energy radiates intense internal heat that drives its violent cloud bands. Out at the edge of the solar system, 3 billion miles from the sun, Neptune takes this to the extreme. It boasts the fastest winds we've ever recorded, tempests whipping at 1,500 miles per hour. This weather is driven by internal heat leaking up from Neptune's swirling, super-dense liquid mantle. The immense pressure inside that methane-rich liquid mantle causes carbon atoms to compress so tightly that they form solid crystals. Deep beneath Neptune's cloud tops, it literally rains diamonds. The most extreme weather in our solar system doesn't come from our star. It is driven by the internal pressure and bizarre geology of the planets themselves. When astronomers search for habitable real estate in the cosmos, they traditionally look for rocky planets orbiting in the Goldilocks zone, distances from a star that are not too hot and not too cold. But our own solar system proves that the best candidates for alien biology aren't planets at all. They are the icy moons orbiting Jupiter and Saturn. Jupiter's moon Europa is encased in ice, but Jupiter's immense gravity constantly pushes and pulls on it. This continuous physical squeezing creates friction, generating enough heat to melt the ice from the inside out and form a massive subsurface ocean. We don't have to guess that this ocean is there. By analyzing images from the Hubble Space Telescope, scientists spotted giant geysers spewing water 124 miles into the atmosphere above Europa's South Pole. We have direct proof of liquid water beneath the crust. Over in Saturn's orbit, we find Titan. It's the only other body we know of that features Earth's geological diversity, complete with mountains, rain, flowing rivers, and deep lakes. But Titan sits at 300 degrees below zero. Those rivers and lakes aren't filled with water. They are overflowing with liquid methane and natural gas, cutting through bedrock made of frozen ice. Finding alien microbes in Europa's dark oceans or Titan's methane lakes would prove that biology doesn't require Earth-like conditions to thrive. It would mean life is likely common throughout the cosmos. Looking up at the night sky shouldn't evoke a static painting. The solar system is a violent, beautiful, and continuously evolving puzzle where planets collide and rewrite their own physical rules. This violent, dynamic evolution dictates our future. Billions of years from now, our sun will expand into a red giant. It will likely engulf the Earth, turning our home into an uninhabitable, molten wasteland. But as the sun expands and heats the outer solar system, the frozen moons of Jupiter will warm up. For millions of years, their thick ice could melt, turning them into self-contained oceans and the last refuges for life. Mapping these planetary plot twists helps us piece together our violent origins. It shows that our solar system is a shifting environment, and it provides clues about where we might eventually go when our own planet's time runs out. Thanks for exploring with us. If you want to keep unraveling the secrets of the universe, make sure to like this video and hit subscribe. Let us know down in the comments which planet or moon we should visit next.